Last video, I promised I'd talk about the Espan Atmosphere, so let's do that today. Atmospheres can often be a hazy topic, pun intended, so let's dive in. Atmospheres of a planet are often tricky because you don't want to exactly mimic the Earth's. Though that definitely is the safest path by far. Espa, just like the Earth, has carbon-based life, which means the bulk of the atmosphere will be very similar to the Earth's. This severely limits our creativity for this video. Or does it? My main goal for Espa is to create an atmosphere that's just on the edge of human survivability, but not quite instantly deadly yet. Let's start off with the pressure. Atmospheric pressure is the weight of the atmosphere, its density at sea level. On Earth, this is just over 1 bar, but on Espa, which is of higher mass, we can expect a much thicker envelope of gases surrounding it. On Espa, the air pressure at sea level will be a crushing 3.07 bars. This will very strongly increase atmospheric buoyancy, which I can later use to make massive airborne fauna, which I definitely think will be cool to have sky whales and sky jellies later on, among other animals. A downside of this though is that the partial pressure of many gases will become close to, if not more than, lethal to humans. This is somewhat intended though, but not all effects of it can be immediately predicted, so I'll try my best not to one-shot any humans going to Espa, but survival is not guaranteed. With that in mind, I think a good way to dive into this is to tackle the composition compound by compound in decreasing order of abundance. Let's go. Our first gas is dinitrogen, which on Earth comprises 78% of our atmosphere, being the most abundant gas by a long shot, and there's a reason for that. Nitrogen is very stable in the atmosphere, and it is not involved to a great extent in the chemical reactions that occur there. Thus, over geological time it has built up in the atmosphere to a much greater extent than any other gas. For Espa we can expect much the same to occur, as the planet is actually older than the Earth. Let's set the N2 concentrations to 61.44%, which is admittedly lower than the Earth, but it still makes it the most abundant gas. This will give nitrogen a partial pressure of 1.91 bars, which, although a lot, isn't directly harmful to humans. Our second most abundant gas will, much like the Earth, be the vital gas of dioxygen, which on Earth is found at 21%. Oxygen is very reactive and thus requires the most of our attention. Oxygen builds up in the atmosphere as a result of photosynthetic life, which exists on Espa. Using sunshine, water, and carbon dioxide, plants and bacteria produce carbohydrates, a process that releases a byproduct, oxygen. Over the last billions of years, the oxygen in our atmosphere has slowly kept building up, and even reached levels as high as 31% during the Carboniferous period about 300 million years ago. Across Earth's history, the oxygen levels have increased and decreased several more times. On Espa, oxygen levels will be high, to say the least, 35.2%, which is higher than they ever were on Earth. To facilitate this, massive tropical rainforests will cover vast areas of the planet, pumping out billions and billions of tons of oxygen into the atmosphere every year. This, in turn, enables large terrestrial fauna and arthropods, and moreover, seriously massive wildfires. While the ecosystems of the planet will get many episodes of their own in the future, for now let's just say that Espan trees will evolve to be more resistant to forest fires than Earth trees. The partial pressure of oxygen will reach 1.09 bars, which is very harmful to humans. It is over twice as high as is recommended for you, and will cause a myriad of physiological issues if breathed at sea level. More on this by the end of the video. That covers oxygen, so let's move to our third gas. Argon is the Earth's third most abundant gas, at just under 1% of the atmosphere. However, this is where Espa starts going off track. Instead of using argon, Espa switches to 2.7% krypton. Both are inert noble gases that don't really react, but this still has some implications. Argon on Earth is almost exclusively found in the argon-40 isotope, which comes from the decay of potassium-40, which provides additional heat to the atmosphere. Krypton is heavier and can be found in the more varied isotopes such as Krypton 82, 83, 84 and 86, which typically decay from bromine or rubidium, which are a lot less common in nature. I'm choosing Krypton to increase the weight of the atmosphere, as well as cut down the heating of Espa just a little. This also gives Krypton a partial pressure of 0.1 bars, which is perfectly breathable. Directly below that we have carbon dioxide, the infamous greenhouse gas on Earth, found at 0.04%. On Espa, with the high oxygen levels, CO2 levels are also massive at 0.22%, which gives it a partial pressure that is 0.007 bars, which is actually mostly breathable. Turns out CO2 isn't really directly harmful to humans as much. But still, this is notably higher than on Earth. These high CO2 levels help facilitate the massive plant growth on Espa. And below this, we have a little argon, 0.14% to be exact. While less abundant than on Earth, it's still present, fulfilling the same functions on Espa as it does on Earth. It is followed by tracer noble gases such as helium at 71 ppm, xenon at 52 ppm, and neon at 42 ppm. Oh, and by the way, ppm means parts per million, and it is a chemical measure that just means in a sample of a million particles, that amount of particles will be of a certain molecule. Then we have chlorine. Chlorine is a very reactive gas, so even in small concentrations it's dangerous to add. I'm adding chlorine for two reasons though. Firstly, I want to have more acidic oceans. Chlorine reacts with water to form hypochlorous acid and hydrochloric acid. This will cause the Espan oceans to acidify. And additionally, chlorine will paint the sky a hazy greenish color. At my concentration of 22 parts per million, that effect is not too strong, but it will still have a coloring effect. Humans can normally smell chlorine at concentrations as little as 0.1 parts per million, meaning the Espan air will smell very strongly of chlorine. Chlorine reacts with water to form hydrochloric acid in the lungs, destructive to living tissue and potentially lethal above 40 parts per million. While Espa is still below the toxic limit, you would definitely feel noticeably ill. Chlorine is also a heavy gas, meaning it accumulates in the low-lying regions. The concentrations here can be so potent, they are enough to cause asphyxiation. On Espa, this creates low-lying death pits, where the chlorine is so potent even the native Espan species can't breathe there. Below this, we have hydrogen at 2.5 parts per million, which lingers around much better than on Earth due to the higher gravity. Nitrous oxide, carbon monoxide, nitrogen dioxide and ozone are found below that. Much like the Earth, Espa has an ozone layer to shield the planet from ultraviolet rays from their sun. Without such a layer, ionizing rays would damage plant life, causing cancer, which evolution sadly can't just develop a tolerance for. However, remember that Ojor is a weaker star than our sun, so the layer doesn't need to be as thick as on Earth. Additionally, ozone is a very light gas, so it floats up into the stratosphere, thus leaving only about 45 parts per billion at sea level. This is good because the present chlorine will severely erode away from the layer. Luckily, the chlorine itself is a good enough absorber of UV. There's even tracer gases such as iodine, ammonia and sulfur dioxide. But beyond that, things get so traced that you would need to measure in parts per trillion, which will barely influence anything, so we can leave this unspecified. Now let's talk about the health effects of the Espan atmosphere at sea level for Homo sapiens. The main toxicity being caused by the oxygen, carbon dioxide and chlorine. For Homo sapiens, the Espan atmosphere is too dense and too saturated with oxygen to breathe comfortably. The partial pressure of nitrogen is over 1.8 atms, which though not directly harmful, has a strong narcotic effect. Additionally, the partial pressure of oxygen is almost 1.1 atms, which is over 5 times that of Earth's, meaning hyperoxia will occur within minutes, and then chlorine concentrations are of near toxic proportions, slowly corroding your lungs. A regular Earth human dropped on Espa at sea level would suffer a slow and painful death, not directly per consequence of the atmosphere, but you would feel extremely drunk, unable to keep a clear focus due to the narcotic effect of the nitrogen. Meanwhile, the oxygen would be clogging your lungs, as each breath you take contains almost 5 times the amount of oxygen your body is used to. The human body has natural antioxidants to help combat this, but these will eventually deplete. It would take hours, maybe days, but you would tire your body out slowly as your organs would oxidize, causing seizures and eventually death. All the while, you are suffering intense skin, chest and eye pain from the chlorine. It is very likely that in this state, you would not survive long enough to be killed by the atmosphere. However, as altitude increases, the atmospheric pressure decreases, and at greater heights the partial pressures of these gases drop significantly. At heights of 4,500 meters or above sea level, the Espan air pressure drops to just 1.4 atms, making it fully breathable to Homo sapiens. The workaround here is to have Homo sapiens colonize the planet from the top down, spawning high up in the mountains and gradually evolving a tolerance to the new atmosphere before spreading into the lowlands. How long this adaptation would take is beyond the scope of this video, but it's a topic we will definitely be coming back to in the future for sure. So finally, let's talk about the sky's color. Due to the thick atmosphere and high oxygen and chlorine concentrations, Espan skies will be predominantly a pale greenish hazy hue, which is deepened slightly by the presence of aerial algae. From the ground, during the day, the Espan sky appears a pale shade of green, which shifts to a deep violet during sunset. Due to the thick atmosphere, some aerial plant life is able to float freely in the thick air, contributing to the green hue. These colorations are strongest during the early noon and slightly desaturate during the mornings and evenings. However, near the poles the atmosphere is too cold for these aerial microbes to survive. Here, the sky reverts to its pure pale blue color, which during sunset transitions to a vibrant red. These colors originate from the higher concentrations of oxygen, but also sulfur-based gases in the upper atmosphere. So that covers all the essentials about the Espan atmosphere for now. I'm sorry this video took like a damn year to make, but ultimately Espan is just a hobby project of mine. Sometimes when you are out of inspirations, it's necessary to take a prolonged break in order to know where you want to take your world. Additionally, there goes so much math and research into these videos that you guys don't get to see, which also takes a lot of time. That said, I've refound some inspiration and prepared a lot of work. I'll hopefully be able to pump out a few more of these videos in the coming weeks. Next video, I want to spend my attention on the map of Espan. Every world needs a good map, and Espan is no different, so stay tuned for that. I'll see you guys next time, GG out.